Okay, this is 10.5. This is one of the most important lessons we're going to learn in this unit and the most challenging. We're going to call this the X method lesson. I'm going to refer to this method a lot in class, so at the top of your paper, please write X method. Okay, today we are going to learn how to factor a trinomial. So far in this unit, we have two factoring techniques. The first one is factoring out the GCF, right, where we find out what they all have in common, circle it, etc., and then put them together. The second one we just learned in the last unit was factoring based on conjugate pairs, where if it's the same number plus and minus, we easily can break that into two factors. Okay? Today we're going to tackle the most difficult factoring method. Okay? And that's when we factor a trinomial, where, for example, a trinomial looks something like this. Let's see. This is a trinomial. We can't use GCF here in this example at the top because they have nothing in common. They have no factors in common. And we can't use conjugate pairs because this doesn't have two terms that are perfect squares. So we have to learn this third idea of factoring trinomials. So the first part of this lesson is going to be review and making sure that we can multiply binomials first. Whoa, my pen just did something really crazy. So the first few exercises we're going to review. So exercise 1 says write each of the following products in equivalent trinomial form. So we're going to do the box method again. On top we have the x plus 5 and on the side x plus 3. I'm just multiplying the box method, and when I simplify I get x squared plus 5x plus 3x plus 15, and this gives me x squared plus 8x plus 15. Okay, please try the next two on your own. Pause and unpause when you're ready. Alright, here are my completed solutions for letters A, B, and C. It's really important to notice that when you multiply two binomials, you get the trinomial. So today's lesson we're going to talk about is, well, how do I reverse this process? Let's say that I start with what I'm boxing right now. Let's say I start and the problem gives me this trinomial. Well, how do I turn it in to this x minus 2x plus 7? How do I reverse this process? I know to use the box method to go this way. If I'm going from this to that, I use the box method, right? But what if I'm going backwards and they want me to get the two binomials? So this is what we're going to learn how to do today, is how to get this trinomial I'm boxing and turn it in to two binomials. We call that the X method we're going to learn. But let's do a little bit more practice with some that are a little more difficult, where now we have, coefficients in front of the x's instead of just x's by itself. So I'll do the first one like I did last time, and then I want you to pause and do the other two on your own. If you want to pause now, please feel free to pause anytime and try these on your own. I really encourage it. We've been doing this long enough now that you should be able to do this multiplication by yourself. So I'm multiplying 2x times 1 is 2x, negative 3 times 1 is 1. I put them all together, 10x squared minus 15x plus 2x minus 3, and I get 10x squared minus 13x minus 3. So go ahead and pause now and try B and C on your own. Alright, so here are my solutions for B and C. Please take a look, check and make sure your signs are correct, check and make sure I haven't made a mistake. I give candy to students who correct my mistakes in these videos, so please take a look. And make sure you're feeling comfortable with this type of math before we get into the X method. Okay? So, in this curriculum, they put this part in here that says that the only method to reverse this process is a guess and check method. Well, I disagree. There's actually a really great method to reverse this that you don't have to use guess and check. So we're going to skip this part of the curriculum, and I'm going to teach you a special X method way that will always work no matter what, besides just guessing and checking, because that will take time and you will get frustrated. So listen really carefully and go ahead and skip to exercise 4, and I'm just going to look at A and B. Okay, so we're going to ignore this directions about guessing. We're not going to guess. We are going to use something called the X method. Okay, the X method is the reverse of the box method. Okay, We use this when we factor. All right, so this right here says write each of the following trinomials in equivalent factored form. That's a clue to you when you see that instruction that you're going to use the X method. So let's take a look at B first. B and A are very different. Do you notice how A has a coefficient right here, that 3? That changes our process a little bit. So I'm going to show it to you on letter B without the coefficient of 3. So we're trying to figure out a puzzle. Okay, we want to figure out two numbers, okay, because when this is going to turn, we want this to turn into something that looks like this, right? We know we have an x squared, so we always know it's going to be x times x, because what's x times x? X squared. But the problem is, what two numbers go here? The two numbers that go there have a special property. They have to add up, or they have to multiply up to this 10 right here. So we're going to put the 10 in this puzzle. They have to multiply to 10. But those two numbers also, at the same time, have to add up to -7, that number in the middle. That is our puzzle. So I want two numbers that multiply to 10 and add up to -7. So I'm going to think of numbers that multiply to 10. So let's think about the number 10. What are some numbers that multiply to 10? I'm going to write them out over here. Numbers that multiply to 10. I have 1 times 10 and 2 times 5. Okay. Now I know I have a -7, so I know one of the numbers when I multiply has to be negative. One has to be negative and one has to be positive, right? Or sorry. When I add up to -7, they both have to be negative, because what's a negative times a negative? A positive. So the only two numbers that will do this would be -2 and -5. Because -5 times -2 will give me the positive 10 that I want, check, check. And -5 plus -2 gives me -7 that I want, check, check. So it's a puzzle. You're thinking of two numbers that multiply to the top number that add up to the bottom number. Once you get those two numbers, after you get those two numbers that multiply to the top and add to the bottom, okay, you're going to take those two numbers and you're going to put them into your binomial. So I've figured out my two numbers. They're -5 and 2. So I'm going to take that -5 and 2. Let me put it in black. And I'm going to have x minus 5, x plus x minus 2. Okay, so my final answer when I factor is this. And just to double check your work, in fact, let me rewrite this up here, actually. X minus 5, x minus 2. We can double check our work and make sure we factored correctly. I can make my box, I can do x minus 5, x minus 2, and when I multiply this out, I should get this original trinomial. So I'm combining my like terms. -5x minus 2x is -7x, and did I end up with what I started with? Absolutely. Okay, you want two equivalent expressions, and you can use this puzzle to figure it out. Okay, what two numbers multiply to the top and add up to the bottom? Okay, this is the X method. It's a puzzle that you have to figure out. All right? Let's try another one without a because once we have this letter A, this coefficient of 3 changes the process a little bit. So let's try another problem on your notes that does not have this coefficient in front of it. So go ahead and skip A for now, we'll come back to it. And let's take a look at letter C. Okay? Now I've got a new one here. I want to try and factor this into two binomials. So I'm going to make my X. On top is going to go the 21. The 21, the last number, the 21 is going to go here. There's the 21. And again, I'm thinking about multiplying to 21. Okay? On the bottom goes my middle number, the 10. Okay? And that's the number I'm trying to add up to. So I have to think about what numbers multiply to 21 but add up to a positive 10. Okay? So I want to multiply to a 21, add to a positive 10. So I'm going to write out my factors of 21. So 21, 1 times 21 is 21, 3 times 7 is 21, and that's it. So now I got to think about this. Is 1 plus 21 10? No. 1 plus 21 is 22. Is 3 plus 7 10? Absolutely. So it's got to be positive 3 and positive 7. Is 7 times 3 21? Yep, so my puzzle works. I can check it here. 7 times 3 is 21, check. 7 plus 3 is 10, check. So my two numbers, 7 and 3, work. They multiply to 21, they add up to 10, so I know that my factored form is going to have a 7 here and a 3 here, and an x and an x. Okay? Again, if I were to check my work and do the box method here and put x plus 7 and x plus 3 and multiply this out, I'm going to get my original trinomial. X squared plus 7x plus 3x plus 21 is going to give me x squared plus 10x plus 21, which is what I started with. Okay, this is my check right here. I'm just checking. This is my answer. All right. Okay. Let's do one more with without a coefficient of 1, because the coefficient of bigger than 1 changes things. Okay, so let's go down to letter G. So here's letter G, go down to letter G, and so here's another one without a coefficient of 1. With a coefficient of 1. So I'm going to draw my x. Okay, I'm going to put my last number, this 12, on top, and the middle number, and you got to be really careful of your signs. It's a -8, so a -8 goes here. And I'm asking myself, what two numbers multiply to 12 but add up to -8? Okay. Now I'm going to list my 12 over here. Okay. Actually, I'm going to do it over here. What are some factors of 12? There's a lot. 1 times 12. Oops, let me write that nicer. 1 times 12. 3 times 4. 2 times 6, and I think that's it. So now you have to think a little bit here, because I have a positive 12, but a -8. Now there are two ways to get a positive number by multiplying. I can either do, let's say I just guess. Let's say I say 3 and 4. I'm guessing right now. It's not actually 3 and 4. What's 3 times 4? 3 times 4 is 12, but what's 3 plus 4? That's 7. Is that what we want? No, so it can't be 3 and 4. But also note, if I picked -3 and -4, isn't -3 times -4 also positive 12? But -3 minus 4 would be -7. So you can still get a positive number here by having two negatives as your puzzle. So signs are really important in this practice. And I notice here, this 2 and 6, if I pick -2 and -6 as my puzzle, it's going to work. Because what's -6 times -2? There's the positive 12 that I want. And -6 plus -2, well, there's the -8 that I want. So sometimes you have to play with your signs. And I know Ms. Vasquez is really good at figuring out what signs go where. And she's going to give you guys a little cheat sheet in her class about the X method and ways to pick your signs. So when I write my final answer, here are my two factors, -6 and -12, or sorry, -6 and -2, so my answer is x minus 6, x minus 2. And like I said, if I want to do a check, I can draw my box, put x minus 6, x minus 2, and do my check. This becomes a positive 12. And when I simplify, I get x squared minus 6x minus 2x plus 12, which combine like terms. There's my -8x, there's my positive 12, and my check works. I get my original trinomial. Okay? So a really important skill, factoring. And when your exponent is 1, it's much simpler. So let's talk about what happens when your exponent's not 1. We have to add in one extra step. So let's go all the way back up to letter A again. So I'm going to go back to letter A on my problem. Okay? And let me draw a line to keep these two problems separated. So there isn't really a lot different with a coefficient of 1. There are two extra steps. So the first step is what's going to be different. So normally, what number would I put in this top part? I would just put the -4, right? When you have a coefficient bigger than 4, are bigger than 1, right here I have a 3, the number that goes up top is these two numbers multiplied. Let me use a different color to show you. So I'll make the last number of this red, and I'll make the first number purple here. Okay? So when I do my x method, the number that goes in top, if my exponent's bigger than 1, I have to multiply these two numbers. So I'm going to pick a times c. Sorry guys, I'm having a problem with my colors. Okay, so a is that 3, and I would have this be my 4. Okay, I'm multiplying the a and the c together. So in other words, my very top number is going to be 3 times -4. That's the only change there in that step. Notice in B, what is the coefficient of this first part? What is the coefficient? 1. And what is 10 times 1? It's 10. So really, you're still multiplying it together, but you just don't see it when the coefficient is 1 because 1's invisible. So when it's something other than 1, you have to see it. It's going to be 3 times 4. So I'd keep my puzzle, the middle number, the same. I'm not going to do this 11. That still stays 11. But now my puzzle is going to become an x with -12 on top and an 11 on bottom. Okay? So the key here is to multiply the first and last number when you have a coefficient bigger than 1. Okay? Now you solve the puzzle the exact same way. You're still looking for two numbers that multiply to a -12. I don't know how I spelled multiply. Multiply to -12 that add up to 11. So I'm going to write out my factors for -12. Okay, I have 1 times 12, 2 times 6, and 3 times 4. But since I want a -12, one of these numbers has to be negative. I could have -1 times +12, or -12 times +1. I could have -2 times +6, or 2 times -6. Or finally, I could have -3 times 4, or 3 times -4. And I notice the only one that will add up to 11 when I look at these combinations is this one right here. That's the only one that will add up to 11. -1 times 12 will give me a -12, and -1 plus 12 gives me a +11. So that's my combination, -1 and +12. Okay? So now we have to do one more thing. Because we did our multiplication first, because this coefficient's bigger than 1, we have to now take each of these terms and divide it by our starting coefficient, which was 3. Okay, so now our two puzzle terms become two new terms. Okay, that's the step to that division. 12 divided by 3 is 4, so my one factor is 4. And my other factor is -1 over 3. I can't simplify -1 over 3 anymore. Okay, so when I write my final answer, okay, I know one of my factors is x plus 4. And my other factor, in fact, let me just erase this for a second here, so I can write this a little easier. Okay, this factor becomes x plus 4, and this factor becomes something pretty cool. We're going to take that 3 that's in the denominator and put it in front of the x. And so this becomes the coefficient in front of x. And this becomes the number after x. So I get 3x minus 1. Very weird steps, a lot to remember, but let me prove to you that this works. Okay? I'm going to have 3x minus 1 on top and x plus 4 on the bottom, on the side, sorry. Now when I multiply, I get 3x squared minus x. This becomes 12x, and this becomes minus 4. When I combine all my terms together, I end up getting that, sorry, this should be an x, that original trinomial that I started with. Okay? So 3 steps to x method. Okay, you got to multiply your first and last coefficient. Okay, that's the first step. Then you solve your puzzle. What two numbers multiply at the top, add up to the bottom? Okay, then you divide by your first coefficient you started with. Then you place it into your binomial form. All right, and like I said, Ms. Vasquez is going to make up guided notes for you guys to have next to you when you're doing these problems. Okay, let's try to do a couple more together. All right, because this is a really hard lesson, and I want you guys to try and follow all these steps. All right. So let's take a look at D. It was another one that I skipped because it had a coefficient bigger than 1. All right, so I'm going to draw my x, and my first step, because this coefficient is bigger than 1, is I'm going to multiply the 2 and the 10 together and put 20 up here. Actually, let me write this a little nicer. So I did 2 times 10 to get me the 20. So I have 20 up on top. Okay, now in the middle, I have a 9. And I'm asking myself, what two numbers multiply to this number and add up to 9? Okay, so I'm going to write out my 20, factors of 20. 1 times 20, 2 times 10, 5 times 4. And right there when I see the 5 and the 4, I can see that 5 plus 4 is 9. I have everything's addition, so plus 5 and plus 4 work here. 4 times 5 is 20, and 4 plus 5 is 9, so it works. But my last step, I can't forget, is I have to now divide each of these by, my pen stopped working, there we go, divide each of these by my start, 10. So I'm going to divide each of them by 10, and I'm going to simplify. 5 divided by 10 gives me 1/2, and 4 divided by 10 gives me 2 over 5. Okay, these are my two factors, and I've got to put them correctly into my binomials using my denominator rule. Okay, so the first one, the 1/2, this goes into this is my x, and this is the one that stands alone. So I'm going to have 5x plus 2, and over here I'm going to have 2x plus 1. The 2 goes in front of the x, and the 1 stands alone. Okay? I can show you the check for this, if you like. If I check this work, remember, I'm trying to get this 10x plus 9x plus 2. If I check this and do my box method, 5x and 2 and 2x and 1, I should get 10x squared plus 9x plus 2. And look at that, I do. This becomes 10x squared plus 4x plus 5x plus 2. And so I have done it correctly. You don't have to do the check. The check is optional, but it's always good to see if your work is correct. Okay, don't forget to divide if you have a coefficient bigger than 1. Like I said, look at letter C. If you don't have that coefficient bigger than 1, there's no dividing, no multiplying. You just get to keep the 7 and the 3. I mean, technically you are dividing by 1 over here, but 7 divided by 1 is still the same number. Okay? So let's do the last two together, the 2 that I've skipped here. Well, there's actually 3 that I've skipped. I know this is a long video. It's a really important lesson, so bear with me. Okay, I won't do the checks for this. That'll save us some time. So I'm going to draw my x for this one. The first thing I'm going to do is multiply my last number with my first number to get a 72. It's a big number. Then I'm going to put my middle number on the bottom, minus 18, and I'm asking myself, what two numbers multiply to 72 but add up to 18? So I'm going to think of factors of 72. So 1 times 72, 2 times 36, 3 times 21, I believe. I think, hold on. 24, actually. 4 is a factor. 4 times 18. 72 and is divided by 6, so we get 6 times 12. And right there, I can kind of start, I can see where I might get an 18 from, that 6 and that 12. Because I need a positive 72, but a negative 18. So if I do negative 6 and negative 12, this fits my puzzle. Because negative 12 times negative 6 is positive 72, and negative 12 minus 6 is negative 18. Okay, so I know that this works as long as this is negative and negative. Okay, so there's my list of my factors and how I found it. But now my next step, I can't forget, I have to divide each of these by 8 because that's what I started with that 8. Okay, these fractions can be reduced. If I put them in my calculator, this first fraction is going to reduce to negative 3/4. So that's my first factor. And this reduces to negative 3/2. Okay? Now I take those factors and put them in the right form. This becomes 2x minus 3. Remember, the 2 goes in the denominator. Sorry, the denominator always goes in front of the x. Okay? And so this would be 4x minus 3 as my final answer. Okay? All right. Why don't you try F and H on your own, see if you can come up with it, just so I can save some time with the video. So I'm going to go ahead and pause my video and do the workout, F and H, and then you're going to pause and try them on your own and see what you can come up with. All right? All right, let's take a look at letter F. So here's my work for F. So first I did my box X method. I made it negative 66 on top because that's 2 times negative 33. I put 5 on the bottom, and then I figured out what my factors of negative 66 were, and I saw that 6 and 11 could give me a 5 if I made the 6 negative and the 11 positive. So negative 6 times 11 would give me the negative 66, and negative 6 plus 11 would give me the 5. Then I did my next step where I had to divide by this coefficient, and when I did that, the left side simplified to negative 3, so I wrote that as my first factor, x minus 3. And then 11 divided by 2 I wrote as my second factor, putting that 2 in front of the x. Okay, so I got an answer of x minus 3 times 2x plus 11. For H was a little bit easier actually. I got a negative 56 when I multiplied the last number times the first number, and a negative 26 in the bottom. At first I thought this would be really hard because these numbers are really big and kind of scary, but when I wrote these factors out, the second factor, 2 and 28, I noticed right away that if I subtracted it, I could get my negative 26 really easily and my negative 56 because I need one of those numbers to be a negative. So I saw that negative 28 plus 2 would give me my negative 26, and negative 8 times 2 would give me my negative 56. Then I had to divide it by that 7, because that's my first coefficient. And on the right side, that simplified to 2 over 7. And on the left side, an easy negative 4. So that became this first factor, x minus 4. And this became my second factor, where again, that denominator goes in front of the x. Okay? This is a really hard process, and I don't expect many of you guys to get this on the first couple tries. So I am expecting you guys to come for help and to ask me and Ms. Vasquez for help doing this process. All right? It's a tough lesson. That's why this is probably my longest video I've ever made, because there's a lot packed into it. So please do your best on the fluency and take it really seriously. All right? Good luck, and please reach out to me if you need help. Thanks.